Alright, so we've already finished up everything with 5.8 yesterday in this class, right?
Yes.
We're ready to move on to the...
Yes. Don't ever talk about 5 point ever again.
Oh, it's so much, Mr. Kenny.
That was one of the easiest ones we've done.
I was gonna say, y'all actually, one, seem to enjoy it, two, that was definitely not the longest we spent on a single task.
Don't say we enjoyed it. We got it done quickly because it was easy. Easier
It
to
was not
grasp.
easy. Fun fact, I think Mr. Logan would agree, elimination is one of the hardest skills for a lot of students in Algebra 1, right?
That was the easiest one for me to grasp.
Okay, well, good for you.
I mean, that's good for you, but it legitimately is one of the hardest.
Would you like
so
to know why
y'all-
it's easier for you to grasp? Because we started with a conceptual understanding of logic, which
100%
always so
true.
upset with me for it. But now we know how to do it so well.
You remember how you were like, oh man, you're making us use logic here. The logic helps build that foundation to be successful later.
Logic to me is just annotation.
It's like we used research.
Well,
to back our-
it's like we use research. The annotation is just noting important pieces of information. The logic is what helps you use those annotations to figure stuff out.
That's just kind of understanding it. That seems like.
Okay. So let's look at our objectives and get to systems of equations, practice, and method sort, which we already did introduce a little bit yesterday.
I'm sorry.
All right. Kelsey, can you read our first objective for us?
I can solve a system of equations by graphing, and by the substitution method, and by the elimination method.
So it doesn't matter which of these methods you're using. What are you essentially looking for with that system of equations? We're trying to
Graph.
Oh.
Solve.
trying to solve. So what are we looking for?
An equal sign.
A solution.
We're trying to look for a solution. Now, what should a solution to a system of equations look like?
Satisfy all constraints to both solutions.
Okay, well, so
Or
to
satisfy all
both.
constraints to both
An X and a
equations
Y.
or inequalities in the system.
Okay, so, okay, you're right. So but we are looking at systems of equations. So we're trying to satisfy both equations, make both equations
True.
true. Let's think about it graphically though, because this is important to think through.
Well, graphically, for an inequality,
But we're looking at
I
equations.
know that I'm just covering inequality first.
Oh, we're looking at equations. We'll get to inequalities for the study guide. I got you. We need to review it.
For
But here's a
equations
system
that
of
we
equations.
intercept.
What are you looking for?
The only possible solution is a point intercept.
Okay, so the point or points
Of
of
intersection.
intersection. Remember, every point on this line right here makes that equation
True.
true. Every point on this line makes this equation.
True.
So this point of intersection makes
True.
both true. Even if you're using the substitution method or the elimination method, what are you still looking for?
The solution.
Which is the
Point of intersection.
point of intersection, right? The substitution elimination method are just algebraic ways to find it,
And
but you also have the graphical way.
going back to inequalities, though, the only reason for that would be because you can have multiple solutions. For this, you can only have one.
Oh, so you're saying like the reason we have to graph it?
Well, I was just bringing that up because you said systems, and for systems with inequalities, you can have multiple solutions to that system.
Yes.
For equations, you can only have one
Solution.
one solution for this.
We're actually going to learn a little bit more about that today.
Actually, you could have more, I guess.
There's a rare case where you could have more, and there's actually another rare case where you actually could have less. And we're going to explore that with this activity. So that's part of what we're doing.
How do you have less? What do you mean less?
That's what we're going to find out. That's a good question.
Should I ever stop getting more complicated? Sorry.
When you quit doing math.
Yeah.
That's like one of the first weeks I ever did CrossFit. I looked at one of my friends who goaded me into it, and I just looked at him and I was like, so when do I stop being sore? And he goes, when you quit CrossFit. Like, that's the only time. You'll just perennially be sore. Like, I don't know if you noticed, but I've been limping for the last 2 days because my legs hurt that bad. Like, when I try to squat down by your desk, it hurts. Anyways, let's get to our second objective though. Because here's what I want you to understand, right? So a lot of times, I'm sure you've heard your parents or your friends or lots of people say, man, math is dumb because I'm never going to use it outside of class, right? And that's exactly what we think. Because like, heck yeah, Mr. Kinney, this is dumb, get me out of here. But no, this is what I want you to see. Yes, Peyton.
Quick question, off topic. Algebra with finance or algebra with statistics, which one's better?
Statistics.
Why?
Because statistics is the study of real world data and learning how to make sense of that data for the benefit of your life. And so all statistics does is look at real world data all the time to understand how to interpret it, which is also really important because their data is always being thrown at you, even if it's not numerical data. You gotta learn how to filter the data out and make sense out of it. Kelsey, ask that please.
So why would finance be not better? Because they would do money, so wouldn't it necessarily?
I'm gonna say this as delicately as I can. Algebra with finance is typically done because somebody, administration, teachers, whatever, think that students can't do a higher level of math.
Oh,
Now, please hear me very clearly on this. I completely disagree with it, and that is why I fight for the end of algebra with finance, because it does not actually develop the skills that students actually need to analyze finance as well. It can be a great course, I just haven't seen it done that way, and I recommend students do Algebra 1 with statistics, and then Algebra 2 is with something else.
Actually, no. Algebra.
I think it's Algebra 1 with probability, Algebra 2 with statistics. That's what it is.
I can identify my preferred method of solving a system of equations based on how the system is set up.
So this is what I was going to say before Peyton asks this. It's a pretty good question, but this is what I was going to say here is most of the time you're like, man, I'll never use systems. Like legitimately, how many times do you think your parents have been given an algebraic system in their everyday life and it's like, hey, graph this and find the solution?
Never, ever, ever, ever.
Never, ever. Well, one, I want you to remember that's because that's just an algebraic representation and we were always basing it on a context, right?
Sure.
Most people, I mean, if you think about 5.8, it was all contextualized, wasn't it? And we converted it to algebra. Most people are unaware of how to take a verbal or contextual situation and make it algebraic. That's one of the reasons why students don't, or people don't realize how math can be used in their everyday lives. There's lots of opportunities. They just don't know how to convert it from words into equations. The other bigger thing, and this is what I really want you to understand. How many times, not how many times, do you think that your parents run into different scenarios or different problems in their everyday life? Not math necessarily, just different scenarios and problems in their everyday life.
Yep.
That happens, right? Now, they as adults or as people have to make a decision about how they're going to approach that problem, right? And usually you want to take the most efficient path to solve that problem. This is what we're learning how to do here. We're learning how to analyze a situation, to make sense out of the situation, and identify, hey, what is the most efficient path to help me find the solution? And that can translate into your everyday life as well. Learning to look at it, look at the situation and say, hey, this is the information I'm given. What's the best way to approach it? Math is not just, hey, learn this one specific skill of elimination. It's learning how to analyze the situation and define or figure out the best approach. Does that make sense? That's one of the reasons, like when I teach math as a content, but I'm always trying to teach you more than just math. How can this principle translate to the real world? I have you constantly working in groups because one, when you talk with people, you're going to learn math better. But two, guess what skill you're probably going to need really heavily in life after high school? Social skills, talking with other people.
Boo.
Boo to you too. But no, like legit, like that's an important thing. So that's why we're always working in these groups. So let's get back to this. Remember, how many systems of equations are there?
20?
20. How many do you have to actually solve?
Like 9?
Only 8. It's 2 by graphing, 3 by substitution, 3 by elimination. You as a group need to choose which ones you're going to do. Who would be willing to jump over? Peyton, you know that's recording, right?
Oh.
Who is a group? You want to go join
Yes,
Corel?
he's smart.
Great, thank you.
you.
Huh?
Does he have to pick a problem?
Well, you all talk it out and figure out what you want to do. It's okay. Just any that you've already solved, keep going with it. Alright, we're all clear on what we're doing?
Nope.
Alright, so make sure you work with each other to figure out which ones you're doing. I noticed
Hey, give
they
me
already have
answers.
some identified. Make sure you identify or you agree with what they're
Wait, we
how
don't
they're
have the
approach it.
same ones then, like.
That's how it is.